Today I'm excited to talk to you about some multiplication concepts that have helped my students who have been working really hard at memorizing their multiplication facts for many years but just haven't found success. And so I tried to switch it around and look at it instead of memorizing the multiplication facts to understand them. And then I believe that the recall will be increased slowly over time, and it gives their brain a chance to develop some of the connections that we want for multiplication. So what we did with this kind of first, the way that I introduce the story is to, or introduce the concept, is to ask why are some facts easier to remember than others. And one of my go-to examples is 4 times 10 versus 6 times 7. Most people remember 4 times 10 much easier because there's a rule that you use to do 4 times 10, which is you add a 0 to make it 40. But 6 times 7 doesn't have as much of a rule, and so it was just a straight memorization, which made it difficult. And so when we look at those rules, we see 3 really easy rules that jump out that almost no students have difficulty with. We see a zeros rule, which is anything times 0 makes 0. We see a ones rule, which is that anything times 1 makes itself. And then we see a tens rule, which when you multiply by 10, it increases the place value, which typically means adding a 0, although technically if we have a decimal or a fraction or some kind of a part, it's increasing place value. It might not be adding a 0. A 0 is just a placeholder for the increased value. But at any rate, so when I start with that introduction, then we go to our multiplication table. And we say, okay, we know our zeros and our ones, so let's go ahead and color those in green. Those are nice and easy. And we know our tens, which is also nice and easy, so we'll color that in green as well. And usually at this point, a student or somebody will say, well, can't we do the facts going down too? Because 1 times 0 is the same as 0 times 1, or I should use an example that's not already called it. 3 times 0 is the same as 0 times 3. And then I get the chance to talk about that as the commutative property, where you can move the order of the numbers that applies to multiplication. So the commutative property applies to multiplication. So anytime we answer a fact in a row, we are also answering the same fact in the column. So yes, we start to see our multiplication table gets pretty filled up relatively quickly. And these are things that we should never spend time memorizing. These should not be on our flashcard set. So if you look at it, if you're learning to 12 times 12, we've actually taken a significant chunk out of the up to 12 times 12 facts just right there in our zeros, ones, and tens. So now after we get those, then we start talking about what is the next easy ones to do. And maybe easy isn't exactly the way to go for it. We should talk about maybe the most useful ones, because what I'm trying to set is benchmarks for your multiplication facts, things that you can use to build off of. And so really what I'm going to do here is the 2s and 5s are the next benchmarks, and those have to do with doubling and halving. And so 2s is doubling, you get to double the digits. Now the halving part is something for students to figure out. A lot of students haven't realized this on their own, but most of the fluent students have, is that your 5s facts, there's a half relationship there where we get to take half of a number and then and add the 0. Or what my students helped me realize this year is if I multiplied something by 10, I could take half of that, and that would be the 5s fact. So any 5s fact is half of the same 10s fact, which makes sense, and it helps you figure things out, which is going to develop your long-term memorization, recall, I should say. Okay, and then while I did that, I also did my 4s facts, because that is a double of the double. So students wound up figuring out that it was easiest to get to 4s by doubling our 2s, and so that's a lot of practice on doubling and doubling. So doing those, I get to mark these facts in yellow. So we talked about our 2s and our 4s and 5s. And so I'll mark those up in both ways. And now you start to see, now that is probably practice. Students might not be fully proficient at those facts yet. So one of the places where I go to practice is homeschool, it's at homeschool math. I always look up homeschool math and then what I'm trying to generate. So homeschool math integers I looked up, and I developed some worksheets to work on. So homeschoolmath.net has different generators, and what I had to do in here was I had to pick, the operation was multiplication, keep things horizontal. I find that 4 by 10 fits on a sheet, and what I did for this one was I made my values not work out, so like zeros, ones, or whatever, and then I picked a list of numbers that I wanted. So in this case I could say 2, 4, and 5 is what I want to practice. And then instead of using the single digit ones where they would recall them or try to be memorizing them, in order to build the system that they're going to learn their multiplication facts, I actually pick ones that are going to require them to do some of the thinking. And by comparison, then those ones at the beginning are going to be easy to remember and figure out whenever they run into them. So I picked values between 16 and 79. I just figured those are ones that they would get to do the like lots of parts to work with in doing our 2s, 4s, and 5s fact. So then I can go ahead and make this a worksheet, and it pops up here, and we see things like 5 times 62, 2 times 71, and I opened up a tool to let me draw on these so you could see how I would be working through these. I'm going to start with this 5s fact. I said 5s was half of 10s, and so what I'm actually going to do is think of my 10s fact is 630, which is pretty easy for students to typically figure out, and I can't draw very well with a cursor, so excuse that. And my 5s fact would be half of that, so my 5s fact would be 315. All right, and that's a little bit faster than the count by system to get there, and it will provide us some basis to work from. I'll look at this. Let's do another 5s fact. 5 times 35. This one is a little bit trickier to do, so the 10s fact there would be 350. And then I need half of that, so half of 300 is 150. Half of the 50 is 25, so I have the 150 and the 25 to put back together, and that gives me 175 as my 5s fact there. Okay, so slicing things in half. Let's see, is there another 5s fact? This 5 times 360, I almost kind of did that one. Let's do 5 times 74. So 5 times 74, 10 times 74 would be 740. All right, half of 700 would be 350. Half of the 40 would be 20. So 370 would be our answer over there. And that is the system we use to learn our 5s a little bit better. Then we'll talk about our 2 system. So I'm going to do 2 times 71, which is going to be doubling. And I like to teach students to start from the left. I think fluent mathematicians tend to work from left to right whenever they're doing mental calculations. Our brain, I think, actually works better when we use the left side, which gets closer, and then we adjust a little bit, as opposed to, I know working from the right side, you never have to worry about borrowing, carrying. They take care of themselves first. But I think our brain is good at scanning for those. And being able to calculate actually easier if we work from the left side over. So I'm going to start from 2 times 71. 2 times 70 was 140. And then the 2 times 1 is just the 2, so 142. I think students usually pick that one up relatively easily. This one I might also do 2 times 77, so I'm going to have that same 140 base, and then the other 14 on top of it, and maybe I'll write it down, or maybe some students would just do it in their head, and so you would see 154 come out of that. All right, so the 2s, I think students are relatively decent at working with.
It's going everywhere.
And hopefully that 2s process has gotten easy enough that we can apply the same thing to our 4s. And so maybe I'll take this example, 4 times 56. 4 times 50 would be 100. The 6 would be 12. So I would double it to make, or sorry, 2 times 50 would be 100. And 2 times 6 would be 12. So I have 112. And then I'm going to double that again. So my final answer will be 224. And as a mental calculation, a lot of people find this easier to work with, going from left to right and building on these step processes to build our 2s, 4s, and 5s. And these will provide bases for us to work on our next set of multiplication facts.